lost all my stored passwords in my Google account today. So I've been having to try to remember all of them. It's been a nightmare. So I went to log into Zoom and realized I don't remember what my Zoom login password is. I haven't had to input it in months. So I got asked about 22, 24, 26, and 26, it has a typo in it, and I'm sure that's why I got asked about it. I think once we clear up the typo, then it's not going to be a big deal. So they asked about 22, and the reason they asked about 22 is this one's going to wind up being a three-part inequality. And for some reason, people are disliking the three-part inequalities. So I have one right here that I made for which the structure is essentially the same, other than I don't have the equal to, but the idea is the same. It's a less than symbol. The absolute value is less than. But really, to understand these clearly, you have to be able to deal with all three possibilities at the same time. So if I take an x plus 4 in an absolute value sign, I could have it equal to 9. If I have the x plus 4, I could have it less than 9 like I do. And if I have the x plus 4, I can have it greater than 9. I can write it all three ways. And fundamentally, what you have to be able to do is be comfortable with the symbol, regardless the symbol that's used. That's the whole point of those first all of those absolute value videos that we did. We started out with the equality, and then we went to inequalities. We're wanting you to be able to handle them however they're fed to you. So the key to understanding an inequality is to understand the equality. If you don't understand the equality perfectly, then you have no hope of understanding an absolute value inequality. So if you don't get this 100%, like you own it in your heart and it makes total sense to you, then these other two, you have no hope of understanding them. That's the first thing that you have to realize. You have to understand the equality first. And if you can understand the equality clearly, then the other two things make a lot more sense. So when we had the videos over this material, what I was trying to drive home was that the absolute value as an operator in mathematics is a distance operator. It's measuring distance. That's what it does. It's all about distance. And it's asking you how far something is from 0. It's identifying a distance from 0. So when I have the absolute value of whatever, if I have the absolute value of stuff being equal to 9, I'm wanting to know what is the stuff that's 9 away from 9. So if you think about a number line, if I have absolute value of stuff equaling 9, the question is, where do I have to be 9 away from 0? Everything is with respect to 0 is what I should say. Where do I have to be located on the number line to be a distance of 9 units away from 0? That's all the absolute value symbol's doing. It's asking that question. Where do I need to be so that I'm exactly a distance of 9 from 0? And the answer is always there's two places you can be. To be exactly 9 units away from 0, I can be at 9, because the number 9 is exactly 9 units away from 0. But I can also be at -9, because -9 is a number that is exactly a distance of 9 units from 0. So when we solve these, that's why you get two answers. You say, hey, I need the stuff to be 9 units away from 0. So if I have this, I'm saying x plus 4 needs to be a distance of 9 from 0. So what does x plus 4 need to be? Well, either x plus 4 needs to be a 9, because then it would be a distance of 9 from 0, or x plus 4 has to be a negative 9. Because negative 9 is a distance of 9 units from 0. So the fact that the negative 9 has a negative on it doesn't impact how far from 0 it is. It just tells you whether it's moving. The negative sign just says, hey, I'm moving towards negative infinity, but negative 9 is still 9 away from 0. How many steps, if you were at negative 9, would you need to take to walk back to the 0? 9 of them. So there's always going to be, as long as this is a positive real number here, there's always going to be two numbers that are that distance from 0. And they're going to be exactly that distance from 0. So once you recognize that all you're doing with this mess is figuring out how far from 0 you are, when you look at this, you're asking a different question. This is saying, I want the distance from 0 to be less than 9. Right? That's the less than symbol. I want the distance from 0 to be less than 9 units. So if you stood out here at 15, would you be less than 9 away from 0? Or would you be like way the heck more than 9 units away from 0? Or if I got down here at negative 20, am I less than 9 units from 0? Nope. So to be less than 9 units from 0, where do you have to be? You have to be between these two numbers. You have to be between those two numbers to be less than 9 units away from 0. So with the less than symbol, you always get the and inequality, because the x plus 4, where does the x plus 4 need to live? It needs to live between the two numbers. If it's outside of those two numbers, it's further than 9 away from 0. So if it has to be between them, then you can put it between them. X plus 4 needs to be between those two numbers. Otherwise, it isn't less than 9 away from 0. And the moment I put x plus 4 between those two bounding numbers, what do I have? I have a 3-part inequality. And I can only make the 3-part inequality because this thing here has to be between the two numbers. Otherwise, it's further than 9 from 0. Does that make sense? So once you set up the 3-part inequality by recognizing that the thing inside of here has to be between negative 9 and 9 to be fewer than 9 units from 0, and it's just a matter of solving it. Subtract 4 from all 3 locations. It has 1 part, 2 part, 3 part. I can't do the same thing to both sides because I have 3 pieces now. So do the same thing to all 3 pieces. So negative 9 minus 4 is negative 13, less than x plus 4 minus 4 is just x, and 9 minus 4 is a 5. So x will need to live between negative 13 and 5 for x plus 4 to live between negative 9 and 9. So once you get this, you recognize, if you're doing it in interval notation, you're going to say x has to be between those two numbers. And really, you're saying x has to be between these two numbers for x plus 4 to be between negative 9 and 9. And if you graph it on a number line, we talked about this yesterday, actually. Don't put a ton of, don't start going in and put 5,000 tick marks. You don't need them. If you've got the 3-part inequality, what's the boundary? What are the bounding numbers? Negative 13 and 5. Just write those. That's all you need. You don't need any other number on the number line. And then recognize there's no equal to symbol, so you're going to get open circles because the negative 13 and the 5 aren't included, and draw the line connecting them. X has to live between them. right? X is between them. So on the number line, X needs to be between them. Is that okay? If you say greater than, you're saying something completely different, right? If I look at X plus 4 is greater than 9, and I think about the number line now, so here's 0, and here is 9, and here is, say, negative 9. If I want X plus 4 to be greater than 9 units away from 0, where will X plus 4 have to live? That's the question that you're asking. Where does X plus 4 need to live to be further than 9 units from 0? Well, there's two good possibilities. X plus 4 could be anywhere to the right? If X plus 4 is 10, then it's further than 9 units from 0, right? I need the distance from 0 to be bigger than 9. So any numbers out here going towards infinity will be bigger than 9 or further than 9 from 0. Or anything going this way is further than 9 from 0. And it's impossible to be both of these things at the same time, right? I can be bigger than 13 and less than 5 at the same time. That's what makes this an and statement. Over here, I can't be bigger than 9 and below negative 9 at the same time. So I have to be one or the other, but I can't be both. So it's an or statement. So what you get out of this is either X plus 4 has to be bigger than the 9. X plus 4 needs to be out here to be further than 9 away from 0. Or what's the other possibility? Well, the other possibility is that the X plus 4 is this direction, which would make it below what? Below negative 9. It can be one of those things, but it can't be both of them at the same time. I can't be 10 and negative 10 at the same time. It can't be a negative number and a positive number at the same time. So I have to connect it with the word or, because it's impossible to be both things simultaneously. I have to be one or the other. And then once you recognize that you have an or statement, you just solve it like we did over here. You get X, you subtract 4 from both sides. Either X is above the 5, or subtract the 4 from both sides, or X is below the negative 13. So now you wind up with an answer that looks different. We still will have the negative 13 and the 5 as the bounding numbers. Those don't change, but where the solution lives changes. So now I have to be, oh, come on. I have to be bigger than 5. So to be bigger than 5, I'm out this way. Or I have to be less than negative 13, which means I need to be going out this way. So an and statement, 99 times out of 100, you get the two bounding numbers, and with an and statement in most physical applications, X is going to be living between them if it's an and, or a 3-part inequality. If it's a greater than or an or situation, X is going to be living off in one of the two directions. 99 times out of 100 in the sciences, that's how it turns out. You can get other things going on, but they're usually contrived.
So would that be considered a no solution if we were like to put that into interval notation?
No, there's definitely a solution. If X is down here,
Negative.
let's say X is negative 15. Plug negative 15 in here. What's negative 15 plus 4?
Negative 11.
Is negative 11 further than 9 away from 0?
Oh, yeah.
Yeah, it is. Any x down here will make the number inside of here big enough so that you'll be further than 9 units from 0. Any x going off this way from the 5, put 6 in there. 6 is to the right of 5. 6 plus 4 is 10. Is 10 further than 9 units away from 0? Yeah. This has solutions. They're just not, they're just what we would call disjoint sets. There's no overlap between the two solutions.
But if it was
So in interval notation, you would just say anything from negative infinity all the way up to negative 13 will generate a number inside of here that's further than 9 from 0. Or any number to the right of 5 will generate a number, when you put it in here, will generate a number that's more than 9 units away from 0. Plug in 100. 100's in this interval. 100 plus 4 is 104, which is way the hell further away from 0 than 9 units. Negative 100's in this interval, right? Negative 100 plus 4 is negative 96, which is way more than 9 units away from 0. Anything between the negative 13 and 5 is fewer than 9 units when you plug it in. You know, you plug 0 in. 0 plus 4 is 4. 4 is way less than 9 units away from 0. So there's a difference between having the distance less than the boundary or the distance greater than the boundary numbers. Here I'm asking the distances to be greater than the boundary numbers, so you're going to need to go to the right or the left of the boundary numbers to make numbers big enough to be further than 9 units from 0. Here I want the distances to be less than 9 units away from 0. So I have to pick numbers that are closer to 0 to be within that. So it's really a matter of thinking about what does that symbol mean and understanding you're talking about distance. I want the distance to be less than 9 units from 0. Well, that means I need to be around 0, right? I'm going to be between here and here. If I step outside of that, then I get distances that are greater than 9 units from 0 when I plug them into the absolute value. So the and situation, when I feed it to you on a test, I'm never going to give you the funky one-off situations that don't show up in the sciences. I'm always going to give it to you exactly like it would show up in a physics class, a chemistry class, a biology class. You're either going to get the distance needs to be less than some amount from 0. So you're going to be between two boundary numbers so that you're close to 0. Or the distance is going to need to be more than some positive real number away from 0. So you'll need to pick numbers that are larger so that you're further away from 0. It's really just the conversation about distance. That's all the absolute value is. And the inequalities are just identifying, do you want to be further than that number from 0, or do you want to be less than that number from 0? And in the sciences, usually this is the more common of the two in the sciences. Because usually what's going on is, for example, in physics or chemistry or biology, you're making measurements. And usually there's some allowable error. And you want the difference between what you expect and what you measure to be within some error margin. You want the error to be less than some amount. And you're almost always winding up setting up a 3-part inequality to describe that situation. So both of these happen in the sciences. The 3-part inequality is the more common. The less than is going to generate the and statement, which is a 3-part inequality because the distance has to be constrained closer to 0. To be greater than some distance from 0, you're almost always going to get a situation where you have two disjoint sets of numbers that don't overlap. Numbers less than negative 13 don't overlap with numbers bigger than 5. There's no overlap, which is why it takes two intervals to describe the possibilities that allow you to be within a distance of greater than a distance of 9 from 0. It's because one way to be a long ways from zero is to move to the right on the number line. What's the other way to be far away from zero? To move towards negative infinity, right? To be far away from zero, to be greater than something, to be greater than some distance from zero, I either need to move towards negative infinity or positive infinity. I need to make the numbers big, positive, or big, negative. One of those two things gets me far from the distance that we're pinning down as the minimum distance we want to be.
I have a quick question. When do you use that little squiggly line instead of just the straight parenthesis?
When do I use the squiggly line?
Well, I don't know what to call it.
When do I report the answer as a set instead of an interval? So over here, if I had the equality, I would report this as a set because there's a finite number of possibilities. This one with the equality sign says I want x plus 4 to be exactly 9 units away. And there's only two ways that can happen, right? If I solve this, I'm going to get negative 13 and I'm going to get 5. And the only way to be exactly a distance of 9 from 0 is to be standing right on the negative 13 or to be standing right on the 5. So I'm putting this in a set because I can list the items. When I write it in interval notation like this, I would be saying every number between negative 13 and 5 that exists works. So here, to be less than a distance of 9, for x plus 4 to be less than 9, I can be any number between negative 13 and 5. And how many numbers are in there? Between negative 13 and 5, how many numbers are there?
12?
No, way more than that.
18.
Way more than that.
Oh, a lot.
Infinity of them. Right? There's not just integers in there. What else? Oh, a half is in there. Hey, pi is like 3.14. Pi is in there. The square root of 2 is a little bit bigger than 1. The square root of 2 is in there. A half of a half is a quarter is in there. A half of a quarter is an eighth. It's still between negative 13 and 5. Hey, a 16th is still in. Every number that exists on the real number line between negative 13 and 5 will work if I plug it in here, even if it looks funky. Plug pi in there. Pi plus 4, is that less than 9? Yeah, because if pi is like 3.14, that's going to be like 7-ish. 7's less than 9. Pi works. So in interval notation, if I give you an interval, there's any interval you make that has a number on one end and a number on the other has infinitely many numbers between them, and they all work, is what you're saying. You're saying it doesn't matter what number you pick between negative 13 and 5, and it doesn't matter how ugly it looks. So it could be negative square root of pi, which is a number between negative 13 and 5, and it works if I plug it in that for x. With the set notation, I'm saying this is it. There's two numbers that work, and that's it. I put it in interval notation. I'm saying infinitely many numbers will work. I can't even possibly list them all. And that's why set notation is kind of a clunky way to describe an interval. You can do it. And we had a video lecture where I described an interval in set notation, but it's not really a good way to describe it. This is a good way to describe it. Set notation, we usually reserve it for when we can kind of like list the things, because there's a finite number of them and it's easy to list them, is usually what we're gonna, it's not, I mean, it's more subtle than that, but in our context, set notation, when I use it with the squiggly lines, I'm saying, hey, here's these three things, and that's it. Interval notation, infinitely many answers that work.
Thank you.
Anything else? All right, so this one got asked about. So I think I've got the structure the same. It's a number that has an inequality that's a greater than inequality. And then it's got two things inside of it. One of them's a fraction, and it's a plusy minus with the fraction. So roughly we have the same, it is the same pattern. It's the same problem style. So again, I'm trying to save the ones on the practice for you to practice on. And then when you want to check your work or you're uncertain, you send me pictures of them. I think I got like 20 people sent me pictures of their work today so far. All right, so absolute value problems, the idea is before you do anything, you want to get the absolute value completely and utterly isolated. So I can probably subtract the 1/6 from both sides. Is that okay? And so we need a common denominator, and the common denominator would be, what's the best choice for common denominator?
12.
12. So we would be multiplying that by 2/2 and this by 3/3. So we'd get 3 times 3 is 9 minus 1 times 2 is 2. We'd get 9 minus 2 is 7/12. Greater than or equal to the absolute value of some stuff. And at this point, you look at this and you say, hey, the absolute value symbol is completely isolated. And then on the other slide, on the previous slide, I said, hey, we're really looking at three situations. We're always looking at 3 situations. We've either got absolute value equaling a number, we have absolute value less than a number, we have absolute value greater than a number. Those are the 3 things that are going to happen to you. And of course, you could always throw in an equal sign in there if you know, that's not going to change things a whole lot. So the thing that makes this problem slightly awkward is the absolute value sign is on the right-hand side instead of the left-hand side, right? Which is fine. You can leave it over there and work through it. But if you get comfortable with looking at them this way, which is what I would suggest doing to start with, get comfortable with the absolute value on the left-hand side, and then thinking through what the symbols mean with the absolute value on the left-hand side, right? Start simple before you try to get more flexible. So all we need to do to get that is to say, hey, I would prefer, and you don't have to do this, but I would prefer my life if the absolute value symbol was on the left-hand side. So stick it on the left-hand side. There's nothing wrong with doing that. The only thing that we have to pay attention to is how is the inequality with relation to the absolute value, and the inequality is pointing at it. See the little tip pointing at it? We have to maintain that. 7/12 is greater than the absolute value. If 7/12 is greater than the absolute value, then the absolute value is less than 7/12. So if I prefer working with it on the left, I just switch it into switch it over to, and it is on the left situation. Does that make sense? Pointing towards it, still pointing towards the same thing. So I just basically took it and just flipped it around. Does that make sense? And then when you look at this now, we want a distance to be what? Do we want the distance to be close to 0 or far away from 0?
Zero or greater? Or what did you ask?
The question is, the absolute value is a distance. So I'm not even going to pay attention to what's inside of it. So my question is this symbol telling me that I want the distances to be closer to 0 or further away from 0? That's the key idea.
Close to 0.
Closer to 0. I want the distances to be less than something. If I want the distances to be less than something, I'm wanting the distances to be smaller, right? If I wanted the distances to get further from 0, I would say let the distances be greater than this number, right? This number is saying how far from 0 is the boundary, and then do I want the distances to be less than the boundary number or greater than the boundary number? So the moment that you know that the distances are going to be closer to 0 because of the less than symbol, it's a 3-part inequality.
Ouch!
The moment you know the distances are less than something, right? That 7/12 is forming a boundary. 7/12, and what's the other number? Negative 7/12. And you either want the crap in here to be living out here, right? There's a bunch of crap in there. So either the crap needs to be out here, but if the crap's out here, it's getting further from 0, yes? Or the crap needs to be between the two numbers, one of the two. It either needs to be between them or outside of them. That's the only two things. And your job is to look at the symbol and decide, is that symbol telling me that I'm between? Or is it telling me that the crap is out here, going towards negative infinity and positive infinity? But if you want the crap to be less than something, you got to keep the crap close to 0. Otherwise, it's getting bigger. So the moment I see the less than, I know I have a 3-part inequality because I want the crap to be between these two numbers. So I say, hey, the negative 7/12 is my boundary, but the crap has to be between them, right? The crap has to be between them on the number line. So the crap's going to live between them. And it's a 3-part inequality with the crap in between the bounding numbers. And now you just solve it. Subtract 3/2 from both sides. So we subtract 3/2 from this side. What are we going to get? They're going to be over 12. So 7/12 minus 3/2 is going to be 7 minus 18. Is that negative 11? Negative 7/12 minus 3/2, because we have to multiply this by 6/6. So it's going to be an 18 in the numerator. So negative 7 minus 18 is like negative 25.
Leave you? Yeah, I left you. What? What? What are you gonna do about it? Kick my ass? When are you gonna kick my ass?
And now what do you need to do next? What's got to happen next?
We need to isolate the x.
You got to isolate the x. So what are you going to do that?
Divide by negative.
Divide by -2 is one possibility. And the moment we multiply or divide by a negative, we've got to change the sign direction. The symbol's got to flip. So there are two ways we could do this. I'm going to flip my symbol here because I'm going to divide by that -2, which will leave the x inside. So you could divide everything by 2, but dividing by -2, I think that's a pain, because what does it generate?
A complex number.
A complex fraction. And then you've got to fight with that thing. So what's the other way? What's the other way to get a 1 on the x? What's the other way we can do it?
Multiply by 1/2.
Multiply by -1/2. Multiply by the reciprocal of that thing. right? So we could say I'm going to multiply everything by the reciprocal of -2, and the reciprocal of -2 is -1/2. So just multiply both sides or all three sections by -1/2. Multiplying by -1/2 is going to be easier than having to deal with this division by 2 sitting down there,
Okay.
right? It's going to make it easier. So we get this is going to be negative times negative is positive 11 over 24. Greater than or equal to negative times negative is positive. We get 25 over 24. And if you wanted to, because which of these two numbers is smaller?
11.
Yeah, the 11 over 24. You could write it so it's kind of in order on the number line. So notice how as long as I keep this thing pointing towards the thing it was pointing to before, everything's still good, right? The greater than was opening towards the 25, the symbol's still opening towards the 25. I just took the whole thing and flipped it over. So on the number line, what does that look like? You got the two boundary numbers, 11 over 24 and 25 over 24. And I've got the equal to symbol, so that equal to tells me that I've got the boundary numbers, but they're included. And where is x? X is between them. Which is why I can write it as a three-part inequality, because x is between the two numbers. And so on the number line, I just darken everything in between the two numbers. If this had been an or instead, a greater than, then I would have made two sentences and I would have used an or. Less than is an and, it's a three-part inequality. Greater than is an or. You get two sentences separated by the word or because the arrows are going to infinity and negative infinity. And you're saying, hey, either get big negative or get big by becoming really big positive. And those are two separate ways of getting big. Questions?
So basically, from what I'm understanding, if it's going to be less than or equal to or just less than, is it always going to be and? So they'll always be in between. And so if it's just greater than or equal to, they'll always be that way. Either way.
Yeah, that's it. It's that simple. Unless it's a contrived situation, because mathematically you can contrive it so that isn't true.
Okay.
It can be contrived. And I just used the word contrive, which means I would be setting up a false situation. It's mathematically a true construct, but it doesn't show up frequently in applications. And this type of class is primarily to prep STEM majors, which means we're getting people ready to be biologists, chemists, physicists, or to take those types of classes. So in those types of classes, if it's an and, it's a three-part inequality, period. That's what it is. If it's a less than, it's an and it's a three-part inequality. You're keeping the distances closer to zero. If it's a greater than, you're putting the distances further from zero, so it's an or. Either get big by going towards negative infinity, or get numerically big by going towards positive infinity. Those are your two choices. And you can't go towards infinity and negative infinity at the same time. So I can't use the word and to connect it. Hey, Israel, I want you to get big by going to infinity and negative infinity at the same time. What's going to happen to the poor guy? He's going to split in half. It's going to tear apart. He can't do it, so I can't connect it with the word and, because that would be dumb.
Okay.
Get big by becoming big positive and get big by becoming big negative at the same time. No, you can't do that. Either a number's getting big by becoming big positive, or like by making a lot of money like Bill Gates. Hey, I'm getting big by it's getting big positive, or oh, I overspent on my credit cards. My number's big, but it's big negative. Right? They're two different things. So you connect them with the word or. There's two ways for your financial situation to have big numbers. You either have big debt or you have big bucks. So you have to connect when it's a greater than, it's got to be connected with an or, because you're telling the thing to get big. Two ways to get big, and they're completely different. One of them gets big by going that way, and one way to get big is to go that way. You can't do both of them. If it's a less than, saying, hey, I want you to stay closer to zero, you get a line interval where x gets to play anywhere on that line. And it's going to be between the two bounding numbers, which means it's a three-part inequality, because where is he living? He's living between two bounding numbers. So a three-part inequality makes a ton of sense. I'm between two things. And when you write a three-part inequality, where's x? He's sitting between two bounding numbers, just like he is on the number line.
Okay.
Anybody else? So it's not as much about memorizing as trying to understand what's going on. Oh, it's a distance, and the distance is either going to get big or the distance is going to stay smaller. What do I need to do to make that happen? That's the concept. Of course, the problem is we try to memorize everything, and then when we try to memorize everything, which is what I did when I was K-12, I tried to memorize everything. But what happens in math if you try to memorize everything? Well, at some point there's like, oh, I have to memorize 5,000 rules, and they just all get jumbled in your head. So it's important to understand concepts, which then eliminates the need to memorize. You have kids, and when your kids are small, you give them rules, right? Look both ways before you cross the road, right? Don't put your hand on the stove. And you give them this big list of rules, right? And it's hard for them to obey all of the rules because there's so many of them to remember, right? But as you grow and develop, what do you do as a child? You start to understand why the rule is there. I look both ways so I don't die. I don't touch the stove because if I do, I'll get burned. And then once you know why the rule is there, it's not a rule anymore, it's a concept. And then you're even able to extend that concept. I look both ways before I cross the road. Hey, I'm on a hiking trail that crosses a motorbike path. Well, that's not a road, that's a trail, but it's the same concept. There could be fast things coming through and I have to look both ways so I don't get hurt. Right? And then you extend that concept into more abstract situations. And that's where math needs to go, or it's always going to be difficult. It has to be, I understand why, so that I don't have to remember why I'm supposed to look both ways before I do it every time. It's the same thing we do with our children. At first, we teach them a ton of rules, and then they internalize. At some point, at least you hope they do. All right, somebody asked about this one. It's got a typo. So when you look at it, it's like it shouldn't even make sense. It shouldn't even make sense. It should be like I should have gotten 52 remind messages saying, hey, Richard, I think there's a typo. It looks like the absolute value bar should have gone here. And if you're doing this, why would that be your guess? Why would you not guess that it was supposed to go there? There's a good reason not to guess that.
Because
You just would have added the two
the
numbers
7
together.
and negative 11.
You just would have gone 7 minus 11. You wouldn't have put two like terms sitting inside of there. So this one, it was supposed to. It looks like somebody typed it really late at night. Is what it looks like to me. It looks like a late night typo. So the absolute value bar is supposed to be there, and it shouldn't be there. So it should have this type of flavor to it. And then it's worth doing just because it plays off of the conversation we were having previously. Hey, you've got 2, 3 minus 2x minus 6 is bigger than 8. And so you've got to isolate the absolute value before you do anything. You've got to get it by itself. So what's your first move? What's your first move need to be? Or what ought it to be?
Would you add 6 to each side?
Yeah, it adds 6 to both sides. And the absolute value isn't by itself right now because right now we have 2 of them. And if it were by itself, we would have 1 of them. We know we have 2 of them because there's a coefficient of 2 on the absolute value symbol. This is what 2 absolute values look like. So the next move would be what?
Divide by 2.
Divide by 2. Is the absolute value symbol isolated now? It is. Is it on the left-hand side where we like it? It is. And now we just have to decide, is it an and or is it an or? Do we want numbers to get big or do we want them to stay small and close to 0? This is a distance, and the distance needs to be greater than 7, which means the numbers can get big because you want them to be bigger than 7 or more than 7 units away from 0. So this is an or situation. So either 3 minus 2x has to be bigger than 7 or right on the number line, the bounding numbers are going to be plus or minus 7 for the stuff, for the 3 minus 2x. And for 3 minus 2x to be, why did I put a negative there? For the 3 minus 2x to be more than 7 away from 0, the 3 minus x could live out here. 3 minus 2x out here would be more than 7 from 0. And 3 minus 2x, if it were this direction, it would be more than 7 units away from 0 because negative 7 is exactly 7 units from 0 and positive 7 is exactly 7 units from 0. So this is an or situation. I either need to be bigger than 7 or I need to be to the left of or less than negative 7. 3 minus 2x could be less than negative 7. Less than negative 7 meaning I'm going this way. Greater than positive 7 meaning I'm going this way. And it's an or because I can't be bigger than 7 and less than negative 7 at the same time. So if I connect it with the word and, it doesn't make any sense. And would be saying be both things at the same time. Be here and here simultaneously. So again, you would rip apart if you tried. So I can't put that word there. And now you just solve it. So next move on this one, what's the next move?
Minus 3.
Yeah, subtract 3 from both sides. Next move,
Divide by negative 2.
divide by negative 2, which is going to take this and do what?
Flip it.
Flip it. What do we do here?
Same thing, minus 3.
Same thing, subtract 3 from both sides.
Negative 10. Divided by negative 2.
Divide by negative 2. That flips the sign. So on a number line, there's,
Isn't it negative 10?
oh yeah, it should be negative 10. You're right. which is going to make this simplify to 5.
Okay.
So the boundary numbers are going to be -2 and 5. And then we need to ask the question, are the boundary numbers included or not included? Not included because there's no equal to. So they're an open circle instead of a solid. And to be greater than 5, I need to be going this way. I'm getting big by going towards infinity. Or to be less than -2, I'm getting big by going towards negative infinity. Those are the two ways to get big. And I want to be greater than a number, so I need to get bigger. As long as I'm big enough, I'm greater than that boundary number. Is that okay?
That's great.
Anybody?
Yeah.
It's going once, it's going twice. I'm going to
Okay, wait,
stop the share if I don't get a question.
Can we review how you would write that answer in
Interval notation?
Yeah, interval notation.
Yeah, interval notation would be, you would say x can be an element of, and what we want to recognize is that the two arrows are completely disjoint. They don't overlap. So I'm going to have the union of two things because I need to describe each arrow separately. I either can be on this arrow or I can be on this arrow. So you get two intervals. So this arrow's going towards negative infinity. And you get to run all the way up to the -2, but you don't get to include the -2, so you don't get to use a square bracket there.
Sweet.
Or you can be another arrow, which is why it's an or. Or there's another possible solution. You can get big by starting at 5 and heading off to infinity. Good luck getting there. Pack a lunch. With the and I don't need to, because when we had the and situation, what did we get? We got a line segment. It was just one thing, so we just needed one interval to describe it.
Mhm.
So we don't connect more than one interval with the and statement. The or, we're connecting two intervals, the two separate arrows on the number line. You gotta say x can be on either one of them, and life is good. Anybody else?
Nope, thank you. This is super helpful.
Yep. There's something going on in the text box. I better peek at it. Oh, it's gone.
Thank you.
Yeah. What's going on in the chat?
Oh, it was just me saying
Oh, it's
things.
just stuff going on in there. All right. I'll upload it into YouTube and post the link.
Sweet, thanks. Have a good one.
Yeah, take care.